So good morning to all of you. In today's class, we will be learning about the digestion and absorption of the most important nutrients. As you are aware, we consume food in the form of in the form of a balanced diet, which includes the carbohydrates, proteins, lipids, vitamins, minerals, etc. And the process of digestion, as you have already learned, so in the process of digestion, these complex food particles, they will be broken down into simpler molecules, and it is very much needed for the absorption of these important nutrients, and finally they will be added to the blood, and that is how we are going to maintain a normal glucose concentration in the blood, normal iron concentration in the blood, normal calcium concentration, so etc. So in today's class, you will be learning about how these important nutrients, that is the simplest molecules of digestion, are being absorbed by the gastrointestinal mucosa in order to provide energy as well as nutrients to the tissues to carry out the metabolic functions. So first I will be discussing about the digestion and absorption of the carbohydrates. So the digestion and absorption of carbohydrates. So you have already learned the various digestive juices with their own position and functions, isn't it? As far as the carbohydrate digestion is concerned, if you all remember the composition of the salivary juice, okay? So the digestion of carbohydrates, it begins in the mouth itself. This is because of the presence of one important enzyme, salivary amylase. What is the other name for salivary amylase? Any idea? It is ptyalin. Pty. So the other name for salivary amylase is ptyalin. Ptyalin. So this is also called salivary amylase. Okay, so this enzyme plays a major role in the digestion of carbohydrates in the mouth itself. So, normally when we take carbohydrates in the diet, these carbohydrates, they are made up of a polypeptide, that is the polysaccharide units. Okay, and this polysaccharide in turn is made up of many large number of simple molecules. They are called monosaccharides. So any carbohydrate, if we consume in the form of starch or glycogen, it should be broken down to monosaccharide first, and the most simplest unit of carbohydrate is the glucose. Okay, glucose, fructose, and galactose. So only these forms of carbohydrates will be taken up by the intestinal epithelial cells. That means they will be absorbed directly by the intestinal cells. So the main motto of digestive system is to break down the carbohydrates into these polypeptides into first polysaccharides into disaccharides or oligosaccharides, and finally to the monosaccharides. Especially the three important monosaccharides are the glucose, the fructose, and the galactose. So now, both the salivary and the pancreatic alpha amylases, they hydrolyze, that is, they break down the bonds which are formed between the monosaccharide units to form a polysaccharide. And these bonds are called 1:4 alpha linkages, but they stay the 1:6 alpha linkages and the terminal 1:4 alpha linkages. So you just remember the salivary amylase, the next important enzyme which is present in the pancreatic juice and which aids in the digestion of carbohydrates is the pancreatic amylase. So these enzymes they mainly act upon the bonds which are present in the polysaccharide and they break down to form monosaccharides. The end products of alpha amylase digestion are nothing but formation of oligosaccharides. Oligosaccharides includes the disaccharides. Okay, so that is the function of amylase. So amylase will not directly break the polysaccharide into glucose unit. Rather, it will convert polysaccharide into oligosaccharides. Then other enzymes which are also responsible for the breakdown of the final bonds, that is 1:6 alpha ligases are isomaltases and exoses. They are rapidly absorbed across the wall of the small intestine. Exoses means they are the sugars which are exoses means we have studied the benzene regulus. It made up of 6 carbon atoms. Okay, so these exoses they are absorbed in the small intestine, and the best examples for the exoses are the monosaccharides, especially the glucose, the fructose, and the galactose. So in this diagram, you can appreciate here. So when we consume a carbohydrate in the form of starch, so this is acted upon by the enzyme, the thiamine, which is otherwise called the salivary amylase. So this enzyme will act on the starch and it will break it into oligosaccharides. Okay, so the thiamine it amounts from 20 to 40% of the digestion of carbohydrates in the oral cavity or the mouth, and the pancreatic amylase contributes for remaining 50 to 80% of the breakdown of carbohydrates. Okay, so now the starch has been acted upon by the salivary amylase and it will be broken down into oligosaccharides. Okay, and this is nothing but the maltose with 3 to 9 glucose polymers. Okay, maltose into 3 to 9 glucose polymers, and finally this will be acted upon by the enzyme maltase. Okay, so finally it will be broken down into glucose, and this glucose will be absorbed very easily in the brush border of the intestinal mucosa. For example, if lactose is present, this is broken down into a disaccharide. It is a disaccharide and this is broken down into lactose and galactose. Okay, so the lactose and the lactase will take the lactose into galactose and finally sucrose into fructose. And all these monosaccharides will be absorbed very easily in the brush border of intestine. Now coming to the absorption process of carbohydrates. So digestion, you know, it is mainly with the help of two important enzymes, salivary amylase and the pancreatic amylase. Okay, so the minor contribution is from the salivary amylase and the major contribution is from the pancreatic amylase. Now, what will happen to these exoses which are formed as a result of digestion of carbohydrates? So, can you name the exoses? They are mainly glucose, fructose and galactose. So these will be absorbed in the intestine. Let us see how these glucose exoses are absorbed in the intestine. So they require a special carrier protein for and they require a special carrier protein as well as the special transport mechanism. Okay, that is special the transport mechanism. The main transport mechanism which is involved in the absorption of glucose is called the co-transport mechanism or the syncope mechanism. What is co-transport mechanism? This you have already learned in transport mechanism. Co means in the same direction, same. Okay. Co-transport means here two molecules will be transported in the same direction. Symport means it is the same mean. Symport means two molecules will be transported in the same direction. So the carrier protein which is involved in the absorption of sodium or the glucose is the SGLT. SGLT stands for sodium glucose transporter. There are again two different types of these carrier proteins, SGLT1, SGLT2. In the intestinal mucosa, SGLT1 it plays a very important role. Okay, so SGLT1 is present in the gastrointestinal mucosa and it helps in the uptake of dietary glucose from the gut. Okay, that means the intestine. So SGLT2 is responsible for the transport of glucose in the renal tubule. Okay, so that we will understand when we teach the respiratory system. So the glucose is transported by Bluetooth into the interstitium and to the capillaries. Okay, so here you can appreciate. Usually what happens So this is a gastrointestinal lumen. Okay, so let us take this as the gastrointestinal lumen. Now here you have the epithelial cell. So this is the brush border of the intestinal epithelial cells. This is the brush border. Okay, so this is called enterocyte. Enterocyte means the cell which is present in the intestinal epithelium. So it is called enterocyte. Okay. So now the digested food particles will be passed through the lumen of the gut. For example, glucose, then fructose or galactose. They all are present in the gut. Now, this glucose needs to be taken inside the cell. So, how it is taken? So, here there is a presence of carrier protein. Okay. So, the name of the carrier protein is sodium glucose sodium glucose co-transporter. Okay, so here it is 1 in the intestine, it is 1. So this carrier protein is present in the brush border of the intestinal epithelial cells. How does it function? So when the glucose binds to the binding site on this carrier protein will not get activated. For its activation, the sodium has to bind to the binding site, another binding site of the carrier protein. So only when both sodium and glucose binds to this carrier protein, this protein will get activated. So there is conformational change in the carrier protein, and if we push the glucose inside the epithelial cell, it will also push the sodium inside the epithelial cell, that is inside the enterocyte. Now, this glucose has to reach the bloodstream. So, this is the bloodstream. So finally, the glucose has to go to the blood. Only the blood will transfer glucose to all the tissues, all the cells in the body. Okay. So how does the glucose will enter will leave the enterocyte and it will enter the bloodstream? This is again with the help of a carrier protein, and this protein is called GLP, GLUT2 protein. Okay, so this is again one more carrier protein which is needed for the transport of glucose from the enterocytes into the interstitium. This is the interstitium outside the tissue space which is present in between the cells of the tissue. This is called interstitial space. So first glucose will enter the interstitial space, then it will go to the bloodstream. Okay, but it will leave the enterocyte via the GLUT protein, that is glucose transporter. Here it is SGLT1 and here it is GLUT transporter. Okay, so please remember these proteins. They play a very important role in the transport of glucose from the lumen of the gut into the enterocyte and from there to the bloodstream. Okay, so remember, even the sodium is getting transported along with the glucose. So this is how the glucose get transported in the glucose get absorbed at the level of the intestine. So the glucose is transported by the GLUT2 into the interstitium and to the capillaries, and sucrose. Okay, so this is about the glucose. So here one protein is shown here, the SGLT glucose protein, which is present in the brush border of the intestinal epithelial cells. So whenever if a question is asked to explain the absorption of glucose, you have to draw the diagram to explain. Okay, so the carrier protein which is present facing the gut of the intestine. So that is the SGLT1, and this requires the binding of sodium and glucose. Okay, so this is SGLT1. So look at this. Here the sodium and glucose will bind to the protein and it will be transported inside of the enterocytes. Okay, and this glucose will leave the intestinal epithelial cell enterocyte via the one more glucose transporter protein, that is the GLUT2. Okay, so please remember SGLT1 and that is the sodium glucose transporter 1 and GLUT2 glucose transporter 2, they are required for the absorption of glucose. Now come to sucrose. It is a disaccharide. Glucose, it is a monosaccharide. Sucrose. Sucrose is getting transported by means of GLUT5 and out of the enterocytes into the interstitium by GLUT2. Okay. So except the sucrose requires GLUT2 transporter GLUT5 out of the enterocytes into the interstitium by the GLUT2. Okay, so this is requiring two special proteins. Okay, so you just remember the absorption of glucose, that is known as energy. Now coming to the digestion and absorption of proteins. So just like your carbohydrates, proteins are also made up of a long chain of amino acids which is called polypeptide. Polypeptide means a large number of amino acids will be bind together by means of a peptide bond. Okay, so here it is called peptide bonds. In carbohydrates, it was called the linkages. Okay, alpha linkages. 1:4 alpha linkages, 1:6 alpha linkages. Okay, but in proteins we call it as a peptide bond. So here we need to break the peptide bond so that the proteins are converted into smaller molecules called amino acids. These amino acids can be absorbed by the intestinal epithelial cells. Now, protein digestion begins in the stomach. Okay, so we don't have any proteolytic enzyme in the salivary juice. So that is the reason protein digestion begins in the stomach, where the pepsins cleave some of the peptide linkages. So the first proteolytic enzyme which acts on the protein is the pepsin, which is secreted in gastric juice. Gastric juice, it is the digestive juice secreted by the stomach. So this is active, this is present in the gastric juice. And what does this pepsin do? It acts on the polypeptide and it will break the peptide linkages. Okay. Now the trypsin, the next important proteolytic enzymes are present in pancreatic juice. Trypsin, chymotrypsin, then elastase. Okay, so many enzymes, proteolytic enzymes are present in the pancreatic juice. So trypsin protein is converted to the active enzyme trypsin by the enterokinase. This enterokinase is present in the brush border of the intestine. Okay, and trypsin, chymotrypsin, elastase, and the interior peptide bonds in the peptide molecules. Therefore, they are called endopeptidases. Endopeptidases and exopeptidases. These are the two different proteolytic enzymes. The examples for endopeptidases are the trypsin, chymotrypsin, and elastase, because they act on the peptide bonds which are present inside the protein molecule. So they are called endopeptidases. Okay. So here you can observe here. So we consume proteins in the food, and these proteins are first acted upon by the proteolytic enzyme pepsin, which requires a highly acidic pH. Okay, and the gastric pH usually it requires a pH of about 6.8. Okay, so during that time the pepsin acts on the proteins and it converts proteins into proteoses, peptones, and polypeptides. Proteoses, peptones, and polypeptides. Okay, so some of the proteins are broken down into proteoses, peptones, and polypeptides. Later, these are acted upon by the trypsin, chymotrypsin, and carboxypeptidases, and also coelastases into polypeptides and amino acids. Okay, so later these in turn act upon by peptidases and they are broken down finally into amino acids. Okay, so the proteins are first broken down into proteoses, peptones. Okay, proteoses, peptones. Then these are in turn broken down by peptidases into amino acids. Amino acids will be finally absorbed by the intestinal epithelial cells. So this is the summary of the protein digestion. So the pancreatic juice mainly contains trypsin, chymotrypsin, etc. So the pepsin is also play a major role in the digestion of proteins. So this trypsin will be present in the form inactive form called trypsinogen. So this is acted upon by the enzyme kinase and it gets converted to active form, that is trypsin. In the same way, once the trypsin gets activated, this trypsin converts inactive chymotrypsinogen to chymotrypsin pro-elastase to elastase, pro-carboxypeptidase A to carboxypeptidase A, and pro-carboxypeptidase B to carboxypeptidase B. So the main rate increased about the limiting step for the digestion of proteins is the conversion of the formation of trypsin. Okay, the trypsin will be present in inactive form trypsinogen. So this trypsinogen is converted to active form, that is trypsin by the enterokinase. Okay, so that is very important. Only when trypsin is formed, it leads to the formation of the active forms of chymotrypsin, the elastase, carboxypeptidase A, carboxypeptidase B. So finally, the carboxypeptidases of the pancreas, they are the exopeptidases. Okay, so which are the endopeptidases? Endopeptidases, they are mainly trypsin, chymotrypsin, and elastases. They are endopeptidases. The exopeptidases are carboxypeptidases, and they hydrolyze the amino acids at the ends of the proteins. Okay, remember the protein structure. It has a carboxyl end and it has an amino end. So these carboxypeptidases, they really act at the carboxyl terminal of the polypeptides, and finally they lead to the formation of the di and the tripeptides. Okay, and the di and the tripeptides, they are transported into enterocytes by peptide transporter protein. Okay, so the di and the tripeptides, they are transported into enterocytes by protein called peptide transporter, and this requires so hydrogen ion H plus ion instead of sodium ion as in case of glucose. Okay, so for the absorption of glucose we require sodium ion. So for the absorption of proteins, that is di and tripeptides, we require H plus ion, hydrogen ion. So where this absorption takes place, absorption of amino acids is happening in the duodenum and jejunum. Okay, even the glucose absorption will be more abundantly occurring in duodenum and jejunum. So it is rapidly seen in duodenum and jejunum. Okay, so this is the luminal side of the gut, and here we have dipeptides and the tripeptides. You can see the molecules here, and they will be transported into the epithelial cells with the help of a peptide transporter protein. Okay, peptide transporter protein, and these once they transport the dipeptides and tripeptides, further digestion of these proteins will be occurring inside the enterocytes, and finally the amino acids will be transported out of the enterocytes into the bloodstream. Okay, so this is how the absorption of proteins will be occurring in the intestinal cells. The third important nutrient which is getting absorbed is the nucleic acid. Okay, so let's see let's learn about the nucleic acid metabolism. So the nucleic acids are split into nucleotides in the intestine by the enzyme, the pancreatic nucleases. Okay, so these are the important enzymes which play a major role in the digestion of nucleic acids. Okay, so the nucleic acids, they are acted upon by pancreatic nucleases and they are converted into nucleotides. The nucleotides are further split into nucleosides and phosphoric acid by the enzymes which appear to be located on the luminal surface of the epithelial cells. Okay, so we can simply call them as nucleotidases. So nucleotidases are the enzymes which will break down nucleotides into nucleoside and a phosphoric acid, that is the base. These bases are absorbed by a transport mechanism called active transport mechanism, which requires 16 molecules for the transport of these substances. Any congenital defect in the metabolism which transport the neutral amino acids in the intestine and renal tubules causes a condition called heart disease. So The heart disease is a clinical disorder characterized by defect in the absorption of the nucleic acids. Okay, so that is why it is and that is commonly Marfan's disease. And a congenital defect in the transport of basic amino acids is called cystinuria. Cystin is a basic amino acid. Okay, any defect in the absorption of basic amino acids is called cystinuria. So the third important nutrient which needs to be absorbed is the fat. Okay. So let's see the digestion and absorption of lipids. So this process is very complicated. Okay. So there are the lipid digestion will be occurring in three different stages. So it begins in the mouth just like your carbohydrates because of the presence of enzyme, the lingual lipase. Okay, so the lingual lipase is present in the salival juice, therefore the digestion of fats begins in the mouth itself. Then in the stomach we have the gastric lipase. Okay, this continues the process of digestion of lipids in the stomach. Then in the small intestine we have pancreatic lipase. So remember the pancreas is for both exocrine and the endocrine part. The exocrine part it secretes the digestive juice, that is the pancreatic juice. So that will be released into the second part of the duodenum, which is nothing but small intestine. So pancreatic juice will also be present in the small intestine, and this contains an important lipolytic enzyme, that is the pancreatic lipase. So the cholesterol ester alkalies and phospholipase A2 also help in the process of digestion of fat, and they are going to complete the process of digestion of the fat. A lingual lipase, this is secreted by the epidermis glands on the dorsal surface of the tongue, that is in the mouth, and most of the fat digestion begins at the duodenum by the pancreatic lipase. And for the absorption of fatty acids, they need to form micelles or micelles. Okay, micelles to be formed with the help of bile salts. Okay, so this is an important step in the absorption of fats. Without forming the micelles or micelles, the fat will not be absorbed. Okay, and these micelles will be formed with the help of bile salts. Okay, can you remember the bile salts? So bile salts are nothing but the salts of sodium, taurocholate, potassium taurocholate, etc. So these bile salts they are very much needed, and they are going to form a complex with the lipid molecules, and this is called the micellar network. Okay. So let's see how this micelles will be formed. So here the bile salts are present on top of the bile acids loaded with the lipid droplets. So to this bile salt, the lipid to this micelle, the lipid molecules they get attached and they are going to form the micelles. So here you can see the fat globule. Okay, this is insoluble in water. Now this has to pass through the brush border of the intestinal epithelial cells. So the solubility will be comparatively less. So these fat globules, so they undergo a process called emulsification. Okay, so the fat globules they do possess the polar and the non-polar regions, and this is you can see on the top of the fat globules the bile salts will get attached, and the fat droplets coated with the bile salts are suspended in water. They become easily soluble in water. This is called emulsification. Okay, so here you can see a bit of bile salts coated with the fat molecules, that is the fat molecules, and they do possess the hydrophilic side which is associated with water, and the hydrophobic side which is associated with the lipids. Okay, so the hydrophobic side means hydrophobic means which is water repellent, repellent. Hydrophilic means it is the water attractive. It is attracting the water. So these hydrophilic cycles is associated with water, and hydrophobic sites it will have lipids on its surface. Okay, so the